Morning students, my name is Lenin Anthony. In the last video session we have gone through electric dipole. In that one of the important derivation we may gone through electrostatic potential at a point due to an electric dipole. It is one of the very important expression in this unit. I believe that you all gone through that videos and you have note down on your notebook. During the interactive session, I have told you have to make a notes on for physics, and in that notebook you have to write all the derivations which will help you during the revision time. And previously two videos that also very important. Electric field due to an electric dipole on its axial line and the equatorial line. Just write all these derivation on your notebook and study that. It is very important 5-mark questions. And today we are going to discuss about a new topic, equipotential surface. Equipotential surface. What is mean by this equipotential surface? You know, in that word equipotential, that meaning is there. Equipotential, equal potential. I will show you. Assume that one charge Q, one positive charge you are placing here. And one charge is placed on a space. Assume that from this place, this is a charge I kept. Now at a distance r, in this point, there will be some electric potential. If you are taking this distance, this place also some electric potential. You know that electric potential V is equal to 1 by 4 pi epsilon 0 Q by R. So this is this formula you have learned already. So this point also, which is at the same distance, so that the electric potential at this point also 1 by 4 pi epsilon 0 Q by R. If you are considering another point at the same distance R, so this point also we can tell V is equal to 1 by 4 pi epsilon 0 Q by R electric potential. If you are considering another point at a distance R, that point also V is equal to 1 by 4 pi epsilon 0 Q by R electric potential. So this side, everywhere, if you are considering the same distance R, all the place the electric potential will be 1 by 4 pi epsilon 0 Q by R. Here also 1 by 4 pi epsilon 0 Q by R. Here also 1 by 4 pi epsilon 0 Q by R. So now you know that if you are connecting all these points, we will get an imaginary sphere. We will get a sphere, isn't it? So if you are taking a sphere, assume that suppose, so like this we will get, if you are connecting all that point, we will get a sphere. So here Q at a distance R. So every point A, B, C, D, every point the potential will be same. So this surface we can tell that equipotential surface. Now if you are placing another surface a distance R1 you are keeping. Now in this surface everywhere potential will be same. If you are keeping another surface, so here at a distance some R2 you can keep. So at all these point, all the point on this surface, the electric potential will be V is equal to 1 by 4 pi epsilon 0 Q by R. This charge is at a distance R1 means on this surface all the point there will be same potential. V is equal to 1 by 4 pi epsilon 0 Q by R. If you are considering the point R on this surface, all the point there will be equal potential on all these points on this surface. This is what we are saying equipotential surface, and you can see the definition. Equipotential surface means, and equipotential surface means what? On which all the points are at the same electric potential, and equipotential surface on which all the points are at the same electric potential. I believe that you have understand this concept of equipotential surface. Now let us go through the properties of this equipotential surface. Assume that like these equipotential surfaces are there, and on this surface assume that you are moving a charge between any 2 points on this equipotential surface. For example, I am keeping on surface here, another surface here. So this surface I am taking VA, and this surface I am taking VB, or you can consider this one. Okay, VA, VB. So now assume that this is an equipotential surface. This is an equipotential surface. Assume that I am taking 2 points A and B, and you know this point, what will be the electric potential? V is equal to 1 by 4 pi epsilon 0 Q by R will be there. And this point also, what will be there? 1 by 4 pi epsilon, same potential will be there. So now you see that the property, what is the first property of this equipotential surface is, suppose assume that you are moving a unit positive charge on charge from this point to this point. So assume that you are moving a charge from a point A to B. Now when we are moving a charge from the point A to B, what happened means, or you can keep that you are charging a charge from this to this. So when you are moving a charge from this point to this point, or this point to this point, some work has to be done. Some work has to be done to move this charge from one point to another point. Understand? Assume that you are moving a charge from a position A to B, so that some work has to be done to move a point, a unit positive charge or charge from a point from one place to another place. That work done, we can tell W is equal to Q into V. W is equal to Q into V. We know that work done formula, W is equal to F into D. F into D means what? F is the force. Here the force producing due to the charge Q, and D means distance. You are moving distance from where to where? VA to VB. So that you can write this equation Q into VA to VB. This is why I am writing here, means assume that a pen is here. Now the pen is having some 25 joule of energy. 25 joule of energy. Now I am lifting this pen from this position to this position. When I am lifting this pen from one position to another position, I have used now the energy is 23 joule. I said when the pen is on this position, 25 joule of energy it has. Now I am lifting this pen from this position to this position. Now its energy is 23 joule. So how much work is done to move this pen from this position to this position? You know that. So 25 minus 23 is equal to 2 joule of work is done to move a pen from this position to this position. That is what here we did some work to move a point charge from one place to another place, or between 2 points, that is equal to W is equal to Q into VA minus VB. So that is the first property of equipotential surface. The work done to move a charge Q between any points A and B is what? W is equal to Q into V. You can write to Q into VA minus VB. Understand the first property? The work done to move a charge Q between any points between A and B, W is equal to QV is equal to what? Q into VA minus VB. Now you can see the second property. Assume that the same is an equipotential surface. You are moving a charge from the point A to B, and this is the first property I explained. So that this example you can remember. And now I am explaining the second property. This is an equipotential surface. From this point A, I am moving a charge to point B. Now you know that equipotential means what? All these point on a equipotential surface, the potential will be what? Same. So all these point potential is same. So if you are taking this potential at A, VA, potential at B, potential at C, D, E, F, all on the same surface, the potential is same, isn't it? So that we know that here potential is same, here also potential is same. So VA is equal to VB. VA is equal to VB means what will happen to this equation? VA and VB is equal. Equal means what? Here 0 will come, isn't it? So the work done also 0. So WA is equal to Q into VA equal to VB. VA equal to VB means what? Both we can write the same. So that here 0 will come. So the work done is 0. That is what? Second property. So if the points A and B lie on the same equipotential surface, work done is 0 because VA equal to VB. So this is what? Second property. If the points A and B lie on the same equipotential surface, work done is 0. What is the reason? Because VA is equal to VB. Now the third property I will tell you. Third property is, assume that this is the charge, Q is the charge, and at R distance equipotential surface, you see, equipotential surface. So these all are we can tell equipotential surface. Now this whole point same line. Now if a charge is there, electric field from will be like this. Electric field. This is what a electric field. Electric field is, always on a radial. It is radially outward. Radially outward. Electric field lines are point outward. This is a positive charge. So electric field lines are point outward. You see electric field lines. So electric field lines are electric field line, 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 electric field line. You see electric field lines are outward. The electric field lines are outward. Now this is an equipotential surface. This is an equipotential surface. This is equipotential surface. This is also. All these equipotential surface you can see 90 degree to this electric field line. You see 90 degree. Check this. So this is electric field line, electric field and equipotential. Electric field and equipotential are 90 degree to each other, or you can tell that normal to each other. This is equipotential, electric field, equipotential, electric field, equipotential, electric field, equipotential, electric field. Now you see how nice it is. All these equipotential surface electric fields are what? Normal to electric field line. So electric field is normal to an equipotential surface. This is what? Third property of equipotential surface. This is one of the very important 3-mark question. First you can learn this equipotential surface definition. It is important to 2 mark, and equipotential surface on which all the points are at the same electric potential. Then properties of equipotential surface. First property, the work done to move a charge Q between any points A and B is, what is the work done? W is equal to QV, Q into Vm minus Vb you can write down. Second property is, if the points A and B lie on the same equipotential surface, work done is 0. Reason why? Because Va equal to Vb. Now the third property of this equipotential surface is, the electric field is normal to an equipotential surface. Electric field is normal to an equipotential surface. So learn these 3 points. This is one of the important 3-mark question. So take a screenshot on this and study this. Now the next part is relationship between electric field and potential difference. Relationship between electric field and potential difference. Assume that somewhere one charge is kept some place. Okay, one charge is kept, Q is kept. That one electric field is like this. This is what electric field. Now this direction electric field, here one charge is kept, Q plus Q. One charge plus Q is kept and electric field is acting in this direction. Now assume that you are bringing a unit positive charge and from this point to this point you are moving. Now you can consider this A, B. So you see this is a electric field. This is the electric field line. You are placing a plus Q charge here. Now you are moving another unit positive charge from the point B to A. Now what will happen means, When we are bringing a unit charge from the point B to A, we are doing some work at a distance dx. Okay, we are moving a unit charge from B to A at a distance dx. For that, we are doing some work. How much work we did? To move a unit charge from the position B to A. So that is dw is equal to, you can write minus E dx. We know what is this E? What is this dx? We know the formula, work done is equal to F into D. And here the force is creating by what? This electric field line experiencing a force. Electric field line experiencing this electric field. Due to this electric field experience a force, electric force. And the distance moved from position B to A is dx. And what is this minus means? We are moving a charge from B to A, that is against this electric force, opposite to this electric force, that is what? Minus E into dx. So dw is equal to minus E into dx. That is what? Work done. And now you see it is an equipotential surface, so that the potential difference at this point and this point is equal. So potential difference we can take dV. Potential difference at this point is equal to the potential difference at this point, so that work also done from this point to this point is equal to same. So we can write this potential difference is equal to the work done. Now you can write this, you can take 1, this you can take 2. Now you can substitute 1 in 2, so that dV equal to minus E into dx, so that you can write minus E dx equal to dV. So E is equal to dV by dx. So minus, this is what the relationship between electric field and potential difference. So you can write this equation. This is only for x direction. Now you can write this equation in vector form. We got an equation only for x direction. You see, this is only x direction. Y direction also you can move this charge. Y direction also move. So all the direction, y, x, y, z direction you can move. So in vector form you can write this equation. E is equal to that same minus, instead of dV by dx, dou v by dou x, I vector, I unit vector. This is differentiation form of this equation. Then dou v by dou y, j unit vector, plus dou v by dou z, unit vector you can write. Okay, so you can take a screenshot of this page. You see relationship between electric field and the potential difference. Consider a positive charge Q kept fixed at origin. Now we are moving a unit positive charge by a small distance dx towards Q in the electric field E. The work done is given by dw is equal to minus E dx, and here minus sign implies what? Work done against the electric field. Now this work done is equal to the electric potential difference, so that we can write dw is equal to dv. Then the derivation I explained already. So you can take a screenshot of this position also I am showing. So take the screenshot in one page and you can study then. Okay, and all of you take your notebook. This question also one of the very important question, 3-mark question in this unit. So today I have taken one important 2-mark question, equipotential surface, one important 3-mark question, properties of equipotential surface, another important 3-mark question, relationship between electric field and the potential difference. Those who have the textbook, you can refer page number 31 and 32. And my dear students, all of you take your notebook, note down all these things on your notebook. It is very important. Thank you all. Bye bye. See you.